Hello and welcome to this session. I am Mohamed Al-Hawi. I am working as a cloud architect at Generali, Switzerland. During this talk, I'm going to tell you about our GitOps journey at Generali, what we did, how we did it, and what we learned. So Generali is an Italian insurance company that is 190 years old. We have two main offices in Switzerland, one in Altlisville, near Zurich, and another one in Nyon, near Geneva. We also have 55 locations across Switzerland. We are around 1,800 employees, and we have 1 million customers. So we started a few years ago a major program to modernize your IT. And what we are doing is that from our legacy system, we are extracting the data in near real time using change data capture technology. And we produce messages to Kafka topics. From there, we have a bunch of Kafka Streams applications that do the data transformation, consuming messages from topics and producing messages to other topics. And eventually, the data are delivered to microservices applications that expose some services through an API gateway to the different channels. We also have Salesforce integrations following this pattern, and everything is happening in near real time. So to support this architecture, we developed what we called the connection platform, or Copa for short. And this is just a container platform offering all the features and services to develop, secure, and operate our systems. And it is compliant with our highly regulated environment. It is deployed on Kubernetes and hosted fully on Google Public Cloud. Some numbers around Copa. So overall, Copa is about 20 clusters running 25,000 pods. We have overall 1,600 topics on Kafka and 550 repositories. We are running about 250 images in production. All this is developed and maintained by a platform team of about 10 people. And we also have a strong partnership with Data Consulting Service. They provide DevOps resources for the business application teams. And they are about 60 people, both on-site in Switzerland and offshore in India. So we didn't start that big with the connection platform, but from the beginning we had some question in mind. So first, what is running on the connection platform? Not only the business workload, but also the platform workload. Meaning we needed to know exactly what is for example, the version of Grafana that is running, and what is the exact configuration of it. So we were thinking about how to have this configuration as code. Automate deployments. So of course, thinking about continuous delivery for the applications, but also automate the whole cluster and its workload. So let's say for some reason we need to redeploy from scratch the whole stuff, that should be automated as much as possible. What is the configuration of my cluster? So again, thinking about configuration of a cluster, thinking about pod security policies, resource quota, storage classes, all this should be configured as code as well. How do we keep track of the changes? So this is really a strong requirement for the compliance and governance. We are again working on a highly regulated environment, and we needed to have this for audit reasons. So this is where our research lead to looking at the GitOps. And very soon we were really confident that GitOps could help us answer many, if not all, of these questions. So in a nutshell, for us, GitOps was really about keeping everything in Git as a source of truth and trigger a cluster update only from a Git push. So this is maybe oversimplified, but it is important to keep that in mind. This very simple concept when things becomes more complicated. So you want to do GitOps, but how to start? We really do like this quote from Adi Osmani that says, first do it, then do it right, then do it better. And these are exactly the steps that we came across during our GitOps journey. And we really didn't want to spend much time discussing what is GitOps, how to do it, and try to come up with a perfect solution. Rather, we wanted to start more small and fast and experiment it and have a quick feedback loop. So this slide depicts the really first implementation of our GitOps strategy, let's say. So when we started back in 2018, we were running Copa on a single on-prem OpenShift cluster. Developers were having their source code repository, and we are just like, let's contribute to this repository with some Kubernetes manifest. So we added the deployment configuration file, all the YAML files into the repo. And we also added a step on the Jenkins pipeline to deploy the applications. So this setup might work if you have an organization with small, homogeneous, and empowered team. But this was not really a good fit for us. Again, we have strong requirements when it comes to security and compliance. And we have one of these requirements is the segregation of duties. So we cannot have the one developing the application being the one deploying it. So sharing a single repository makes it difficult to fulfill this requirement. Another issue that we have is that the last step on the pipeline that we added. In this step, we were deploying a tagged Docker image that was just built in the step before. So for this to work, we had to patch the deployment manifest with the newly created image tag. So this is an imperative approach rather than declarative. And this is not really good because whatever you do imperatively is lost either in your bash history or in your pipeline logs. So we wanted to have a fully declarative approach here. Another issue that we had is that was that there was no cluster synchronization. We are only applying the YAML file, the manifest blindly, and then it was not easy to have the cluster state picture and to track the changes. So we did it right, let's say, in the next year. So first thing is that we splitted the repositories into application build repository and application deploy repository. So the build repository is used to build the Docker images, and it is what triggers the CI pipeline. The deploy repository is hosting the Helm charts to deploy the applications. And when a new tagged image is built that needs to be promoted, the image tag is updated on the deploy repository. So we have a very fully declarative approach. We also introduced a special repository that we called Cabana. This repository holds references to all the deploy repositories. And this is really the desired state of the cluster. This is our source of truth. So also Cabana contains all the configuration specific to the cluster. So like the pod security policies, the resource quota, network policy, and so on and so forth. So looking at Cabana, we can tell exactly what is deployed on the cluster. The Cabana repository is owned by the platform team, but the developers can contribute to the Cabana with pull requests. So if they want to promote a new version of the application, they can just issue a pull request and it is merged by the platform team. To complete the setup, we also have developed our own sync tool. So the reason for that is that at the time we had a lot of automation scripts, and all we needed was just a simple web server to listen to Git webhook and execute the scripts. This was really the easiest way for us. So our sync tool was also generating some human readable reports on every change happening on the cluster. So what was missing was that this tool was only able to synchronize one way from Git to the cluster, but not the other way around. So we didn't want to invest much time in developing this feature because we were already looking at Argo CD as a standard tool to do that. So then we did it better. This slide shows the state of the actual solution that we have implemented for GitOps. There is quite a lot of information in this slide, but don't worry, we will deep dive on the different parts in the next slides. So what I can tell is that yes, a lot happened during the last iteration, and most specifically, we have migrated to a multi-cluster environment, and we are running on the Google public cloud. So we have now specialized cluster like streaming cluster for our Kafka workloads, or business cluster for the business applications workload. And we also have a different cluster for each stage. So for example, we have the business devel cluster or the streaming test cluster. You can also see from the diagram that we have adopted Argo CD, and we deploy it on each and every cluster to manage the synchronization with Git repositories. So the real challenge that we faced with that many clusters was to find really the right structure to support our GitOps strategy in a compliant way. I'm now going to hand over to my colleague Almir, and he will show you.
In our setup, there are three different kinds of repositories: cluster repositories, product inventories, and application deployments. Cluster repositories contains patches for different kinds of resources. It's mainly used to add cluster or environment context into the Kubernetes resources. For example, based on the cluster stage, an additional values file will be referenced from the Argo CD application. With this approach, the same application deployment can be used to deploy to multiple stages. The cluster repository has references to the product inventories. The references are built with Kustomize to be able to patch the resources on cluster level. This approach requires the cluster repo and the product repo to be built with Kustomize. The cluster repo follows the app of apps pattern. It creates an Argo CD application for each product. Product repository is used to group a set of deployments and to empower the inventory owner to manage their own namespace, where his applications will be deployed. We provide a customized manifest, which can be used to set up a namespace and all required resources around it. The product repository follows as well the app of apps pattern to create Argo CD application for each microservice. The application repository will deploy the application itself. It's a plain Argo CD application, so it will support any tool Argo CD itself supports. In our case, some are created using Kustomize, for example, the Argo CD deployment itself, but most of the applications use a common Helm chart maintained by our team. This picture illustrates the connections between the cluster and the inventory. We have split the tools we as a team provide in multiple inventories, which we can deploy independently on a cluster. For example, the CD inventory, which creates a namespace for Argo CD, and Argo CD application to deploy Argo CD is referenced on each cluster, whereas the CI inventory, which provides the CI pipelines to build images, is just required on the management cluster. This separation gives us the option to deploy inventory on multiple clusters, or if required, to move an inventory to a new cluster. The cluster repository contains different stages, as folders and branches. On each stage we point to the right folder branch combination. For example, on devel cluster, only the folder devel from the branch devel is referenced. The same approach used for every cluster and stage. Our goal was to be able to make changes on the cluster without anybody needs to touch the cluster or update a revision in an application. This is only possible if the root Argo CD application points to a branch. From the cluster repository, we reference inventories either by branch or tag. On lower stages like devel and test, the inventory can be referenced by branches, and on acceptance and prod, only tags are allowed. This makes it less error prone, as changes on the inventory can be tested from develop or master branches. Depends which branch is referenced. Using this folder branch combination allows the inventory owner to create a merge request to deploy his inventory on a stage. The branch which is used for the merge request will contain the changes for all stages, and a separate merge request will be created per stage. Multiple iterations per stage are possible. This means for a release and an auditable deployment of an inventory, it requires a Git tag and some merge requests on the cluster repository to update the reference to the newly created Git tag. As in our case, we have a shared cluster. Every team must be able to deploy their own changes independent to others, which means they will create merge requests for inventories when their inventory needs to be deployed. Some guidelines have to be followed, otherwise the branches will not be mergeable. As the whole process relies on Git, we can use Git log as our logbook. We know at every time what is the state of the whole cluster. The best thing about the whole GitOps approach is all changes are stored in Git. It is auditable out of the box. There's no need to build a process around it. In our case, there is a lack of automation. So as we focused on the process and how to bring changes to production, there are still some manual tasks to do it. The tags and merge request needs to be created manually. Also, multiple tags are required to update if you update the Docker image. There are a lot of Git branches and tags around it. So you have multiple branches on the inventory, you have multiple branches on the deploy repository, on the build repo, and so on. So the same goes for the cluster repository. It makes the management complex. And still not sure if this is the final solution. An important point is to start early and to see the problems and to be able to adjust where it is required. With this said, we are on the end of the presentation. So thanks for listening and see you.